Greetings, the Astro 30 here yet again, and welcome back to AEL. Now, if you're new here, please consider going down below and subscribing if you haven't done so already. That will really help me out. Bonza. Now, I normally don't do CD players because, well, I don't have a real great success rate with them because I just do not have the test equipment to properly align them. You need really an analog oscilloscope, and even some CD players don't even include the EFM test point to even measure your eye pattern to get the thing to track and focus correctly. Also, laser pickup assemblies are very hard to come by these days too. So, however, I've got sitting on the desk here a Kardon, a Kardon, a Harman Kardon. Yes, I did that on purpose. CD player. It's just a normal compact disc. I don't think it's a DVD. No, it's just digital audio with text. So it has the CD text reading capability as well. It's a HD990. And the complaint on this is it's completely dead. So let's verify that by finding a suitable plug. I've got one just sitting here, but it's fairly short. Now, it's completely dead. I'm not really worried about blowing stuff up like it or the main house fuse or anything. So let me get that plugged in and we'll have a look. Alright, I've got the unit plugged in now and I don't see anything or any signs of life at all, but it most likely is because it's in the off mode. However, if I push the power button, nothing. No display, no activity, don't even hear the mechanism doing anything inside. It's also scratched the shit as well, which is a shame, but yeah, that is completely and utterly dead. I hit the display button, nothing happens. Power button, nothing happens. This thing is completely dead. So I'll unplug it and we'll rip the top off. I've already removed the screws previously. Let's make things a lot easier. There we go, the lid's off and it's a bit bowed. And it'll straighten back out. Right, so there's the actual power supply itself, and it is switch mode. Well, part of it is switch mode. We've got the AC coming in over here through a EFI filter or RFI filter, and main filter capacitor. That little IC down there, I believe, is the pulse width modulation controller IC, and the capacitors don't feel bulged. It goes into the chopper transformer. There's probably a MOSFET around here somewhere driving that, but I don't see one offhand. Got the opto isolator down here, so this is the high side, and this is the low side. It's then rectified, and they use some linear 7/8 series regulators to get the various different voltages. And lastly, they've marked what each of the voltages are on these connectors, which is handy. So there's a good look at the inside of it. It's a fairly clean design, and they've used black solder mask. I guess they want to be different. Here's all your digital and analog circuitry over here for controlling the CD transport mechanism here. Bog standard little laser here, which is free and moving smoothly. So that's fine, but it's not at its home position. Spindle motor feels okay. So this would definitely most likely be a power supply issue, and it does have a fuse here for the AC, but it is not blown. Not as far as I can tell by looking at it. I could measure that, but I'm pretty sure it's not blown. So we'll verify that. Right, okay. Let's test this fuse. It is not blown. Okay. It's always good to check because you can't just assume things. It's a really nice powder coated case too. The issue is most likely going to be capacitors in the power supply itself. Mainly all these low side ones, mainly the ones to do with the actual switch mode side of the supply, not the linear side. I can't feel or see any obvious bulging capacitors, but most likely these lower voltage value capacitors and these low ESR ones especially may be faulty. I'm not sure what values we got in here, but if you see a capacitor in a switch mode power supply that says like 1000 microfarad 10 volt and the power supply is dead, change it. Those ones in a lot of the switch mode power supplies were notorious for failing because they're just undervolted for the job. Yeah, I'm not sure what value that is. I can't read it. It's a 4.7 microfarad, 160 volt cap, so that's on the high side, so that's not really relevant. There's a 1000 something there. 1000? Yeah, 1016 volts, so that's fine. This will most likely be the linear side. We've got a BA338CB there, an LM317T there, and as for what that is, I can't tell you. That is a L7805, so that's a 5 volt regulator. So I'm not sure what the BA is at this point. There doesn't appear to be a MOSFET or chopper to drive this, which is interesting, I guess. But it as I said, most likely would be dried out capacitors. More likely probably this one here, because that's the only low voltage one that I can see in this circuit. Not that I can see what its value is either. Let me just check that off camera and I'll get back to you. 47 microfarad 50 volt. So there is going to be quite a lot of caps in here to change. We've got 2, 4, 6, 8, 10, 12, 14, 16, 17 of low voltage ones. So I reckon it'd be most likely just to replace this lot, because I reckon these other ones are all to do with linear. It's a good starting point. So yeah, I'm going to have to get a bunch of capacitors and just try it, because there's not much I can really test here to see why it's not working. Voltage measurements are probably not going to yield anything. However, we could measure if we've got a 5 volt rail at least, the plus minus 5 volt rail. Probably not. But the 5 volt rail is responsible for powering the microcontroller plus the standby circuitry. So if that's not present, it's not going to do anything. So I'll go between, well, that's the A 5 volt rail. So I want the digital 5 volt rail, which is D plus 5 volts. So that's here, digital ground is there. So this one we should have plus 5 volt, which you can't see the meter, but it says absolutely bugger all. And then there's the second D 5 volt rail, which is absolutely nothing. The 3.3 volt rail, which would be for the micro, but there's nothing there either. We've got an M plus 5 volt and M ground, so I don't know what that's for. But again, there's nothing. So I'll go between normal ground, A ground, I believe, that one there. So we've got audio plus minus 5 volt, there's nothing, absolutely no voltage at all. which is unfortunate. However, I didn't think there would be. So, yeah, we've got an issue with the switch mode power supply just not turning on. Yeah, as I say, it's most likely capacitors. So I'm going to get hold of a bunch of these capacitors after reading what their values are, etc. and start recapping. I'll start with, well, this one, that one, that one, and that one. I'm going to leave the 100 volt alone, and I'm going to leave the 400 volt 82 microfarad over here alone. But yeah, I'm just going to change the capacitors in the control section and on the high side here, just to start with. And then if that doesn't yield anything, I'm probably not going to go much further with it, but it's worth a try. The power supply is out of the unit. It's actually several weeks later because I've been putting off doing this. So the thing is fully discharged because it hasn't been plugged in for over 3 weeks. But I will stress now that if you're doing something similar at home, please be careful. These have the potential to be fatal because of the high voltage DC that's on this filter cap, which is in this country 380 volts DC. That's enough to give you a bad day, if not kill you. So just, you know, err on the side of caution with these things, because myself, switch mode power supplies and I have a love-hate relationship. Anyway, I'm going to replace these two capacitors. I've got enough capacitors to recap the entire thing, but I'm going to start with these two because this is in the oscillator section. And if these have become electrically leaky, i.e. turning into a resistor, then the thing is going to fail to oscillate. So that's where I'm going to start first. I've checked every other component like resistors and diodes, transistors, make sure we didn't have any shorted regulators here. Everything seems to check out. The only other two things that could be wrong with this is the opto coupler down here or the PWM controller IC here. I've checked the windings of the transformer to make sure that they're intact on both the primary and the secondary. They are. I've also found the schematic to it, which gave me a better idea of how this thing is put together. So that's very helpful. Now this one is a 160 volt 4.7 microfarad capacitor. Unfortunately, I can't get one from JCar, so I've got a huge one, a 450 volt I think it is. Yeah, 450 volt. And it's almost twice the size, but it should just fit in there. So that's what I'm going to be getting on with, is I'm going to turn this over. I'll start with this large capacitor here, large in as in its voltage, physical size I suppose. Probably would be a good idea to go through this board and resolder some joints as well, because some of them are looking a little bit sad. So if I can get this to melt the solder, that'd be great. There we go. So I wonder if this will pull out now. No, it won't pull out now. It's still attached here. Now it's out. Okay, so that positive's that way around. So I need to put the capacitor in here this way around. It sort of fits, but it's coming into contact with that resistor, so I might leave him slightly high or proud of the board so it's not interfering with any other component. Just like that, that should be perfectly fine, I think. So I'm not going to take too much footage of, recapping the board, because what is the point? It's not going to really be that entertaining. But we will just do these two capacitors here. I've also got to check whether or not we've got the standby voltage, which is 5 volts constant. If we don't have a standby voltage, well, the thing's never going to operate at all. So that's that one capacitor done. So cut the leads off. Now I need to unsolder that one there, which is that one there. I can see that joint is not that best on that resistor either. So So these capacitors I'm changing are the main filters for the oscillator circuit. And as I said, if these have turned into a resistor or starting to, i.e. they're electrically leaky, they're not going to filter the line correctly, and it's going to cause the thing probably not to oscillate. So take that one out. I'll get a new 47 microfarad 63 volt. This is a 47 50 volt low ESR. This isn't a low ESR, but I don't think it really matters for this application. So positives that way around, I believe. Yep, positives that side. That fits in there nicely. I'll be happy and I'll laugh if this operates now, but I'm not going to hold my breath on that because, well, as I say, me and switch mode power supplies have a love-hate relationship. Alright, now I'm going to put the power supply back in the unit and do some testing. Okay, power supply is back in the unit, and again I'm going to stress caution here. There is 380 volts DC potential around this area of the circuit board, so keep your hands well away from that side of it. If you're doing something similar at home, you do so at your own risk. Anyway, it's plugged into the dim bulb. We should see an initial inrush of current as this capacitor charges. That will indicate that we are actually getting the high voltage DC. But everything's hooked up, it's grounded properly, so well, absolutely nothing happened on the dim bulb. And if I hit the power button, no, it's still dead. Okay, so that is kind of disappointing. So what's the next step? I think what I should do is measure to see if we've actually got the high voltage DC here, and also whether we've got the plus 5 volts standby supply. So I need to go grab a multimeter. So to measure the high voltage DC, I can do that on this side of this large power resistor and ground. And then I'll measure on the other side of the resistor. That's a 380K, I think it is, 360. Yeah, 360K. So my positive probe will go there, and that will go to ground. And that'll let me know whether or not I've got the high voltage DC supply at this capacitor. Alright, so the meter's there, and I'll turn him on. Very carefully do this. And we don't. We have absolutely no voltage there. What about this side of the resistor? Nothing. This resistor? Nothing. Well, that's interesting. We've got absolutely no power, DC wise, coming after the rectifier. So if I probe around the rectifier, nothing, 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 nothing. Alright, do we have AC voltage coming in? That's another thing I didn't check. This is why it's probably a good idea to do voltage measurements first. AC wise, right, well we're here. Yes, we've got the AC voltage there, 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 not there, or there. We've got the AC voltage there, so we should have an AC voltage across, and we do. So it's going to the bridge rectifier, but it's not coming out again. That's perplexing. So we've got voltage coming in, but nothing coming out. Oh, we do now. We've got 219 volt DC roughly there at the bridge rectifier. Okay. Let's try that. There it is. It must be not related to ground. Oh, it wouldn't be. It's bipolar. Of course it is. Alright, so we've got voltage going to there. It's only limited because we've got the dim bulb in circuit. And on the other side of that large resistor we've got about 0.08 of a volt. So it's experiencing a voltage drop, but it's not actually supplying voltage as it should. But so I know we've got voltage coming in, nothing is happening there. So yeah, the next step would be to measure to see if we've got the DC voltage for the standby circuit. If that's not there, then it's not going to operate. Get in there. In fact, I might do it across the connector. 5 volts should be that side. Nothing. And nothing. There's absolutely no voltage there. Okay, so it looks like this thing is not oscillating. Okay, so I'm just going to see what voltage we've got at pin 3 on this PWM IC, which is the VCC line. We should have, I don't know, this IC's maximum voltage is about 30 volt DC, so we should see something around there. And even if I can't fix this thing, I'll still upload the video. Because, well, it's kind of interesting. So I need to find the ground as well, which is pin 2. Oh, that makes it awkward. Well, it's just the negative of the bridge rectifier, so the negative over there, positive here. And, well, yeah, we've got that 0.084 volt there, which is not enough. So it could be the dim bulb's limiting it too much. So what I'll do is I'll plug this directly into the supply line, the power point, and see if we get a different voltage reading there. Alright, it's plugged directly in now. So the negative of the bridge rectifier and pin 3. Still 0.08 volt. Yeah, it should be a lot higher than that. So that's kind of interesting. And I'm looking at the schematic where that 360k 1 watt resistor is, and well, as long as you've got the close to 380 volts DC on the other side of it, which is here and here, you've got 219, so it's kind of under. But then again, it's only a small value capacitor. It's only like 68 microfarads, so it's probably not bringing the supply up high enough, but whatever. So that, and it's also going through one side of the primary of the transformer here, so that may be having a limiting factor to it as well. But we have not got the correct voltage at the VCC here, so it's never going to operate when it's like that. I could try disconnecting the main outputs and see if that makes a difference. No, it doesn't. So we need 3.3 volt there for the CPU, and there's nothing. So analog plus 5 volt, nothing. Analog negative 5 volt, nothing. So this thing is it's just not generating any voltage, and it's yeah, because that low voltage on the other side of this resistor is not going to be helpful. Why is it that low though? However, it could be that the actual switching IC is actually damaged and is holding the supply line down, because it might be an internal short somewhere. So yeah, I reckon this IC is probably faulty, and I don't have another one, and they're also obsolete. So I think For this one, it's going to be put in non-repairable at this stage, unless anyone's got any other ideas. So I will upload the video just for your enjoyment, and it's a look at what the quality of Harman Kardon products are. But yeah, because this is a weird IC. It's I think it's an MK, but it's a KA5L0365R PWM controller IC. I doubt the opto coupler is bad. I reckon it's most likely the IC itself. I should probably unplug that before sticking my fingers in it, because I do not want to get zapped with 218 volt DC. So yeah, I reckon that's the issue, is that IC is dead. It's the only thing that can be, because I've checked all the other components, transformer, etc. These inductors here are working fine. They've got like 2 ohms of resistance on either coil, so it's passing the voltage through. And it's obviously passing the voltage through because we've got 218 on the side of this large power resistor. So yeah, I might look into probably seeing if I can order the IC, but then again, is it genuine? I don't know. But yeah, I think it's probably not worth investing in it. Now, there's no point replacing the capacitors on this side, the low current side of the, or low voltage side of the circuit, because, well, they're only linear regulators, and they're just main filter capacitors for that. So it's not really that important. I was just mainly concerned about these capacitors in the oscillator itself. Is it likely that this filter is bad? No. I've never seen the large main filter go bad in any switch mode power supplies. Usually always the low voltage capacitors. Anyway, so yeah, that's where I'm at. I'm going to leave this one here because I don't want to take up too much time with it. So yeah, I'll throw the top on it for now and look at doing something else a little bit later to it. So anyway, if you enjoyed this video, please remember to go down below, rate, comment and subscribe if you haven't done so already. And as always, this is the Astro 30 saying, see ya, have an excellent day. Harman Kardon. You had me at Harman. I mean Kardon. I mean Kardon.